Hello everyone, my name is Amir and I'm engineer here at Semaphore. I will share with you our journey of improving the Semaphore API. In the next 10 minutes or so, we'll try to briefly go over our current API infrastructure state, our vision of improved API with a more cohesive, maintainable, and developer-friendly experience, hopefully not just for us, but also for our users. Some guidelines that we established based on experience, and finally I'll try to give some pointers if you're interested in contributing or giving some feedback. I'll be honest with you and say that our current API isn't exactly where we would like it to be. Over the years, we accumulated multiple different approaches of serving our API, each posing its own set of challenges. Part of the API is defined with gRPC and protocol buffer. It uses a gRPC reverse proxy that translates between RESTful HTTP API and gRPC. The gRPC calls are implemented across multiple services, or gRPC APIs are implemented across multiple services, and then each service needs to maintain both internal and public APIs, which is not ideal. And then also we had issues with translation between HTTP and gRPC that didn't always work as we expected it to. So it proved a bit more cumbersome than what we would like it. Some of our services also expose their own HTTP APIs. This wasn't ideal because maintenance becomes increasingly complex as we add more services. Our third and most promising approach is the one we chose to improve further, and it's a dedicated service acting as HTTP server, and this service then translates incoming requests into our internal API calls with the full control of the translation. The same ones that so we are using the internal API, the same one that we use for inter-service communication. What we love about this approach is that we have a centralized implementation for security features, a single point for implementing response formatting, single point for validating requests, and it's generally easier to maintain and update. Taking these lessons to heart, we are unifying the API under a single cohesive approach, and the goal being to provide a consistent, predictable experience, making it easier to integrate with Semaphore. Hopefully also making it easier for other developers to extend our API and keep the documentation up to date. With these goals in mind, we landed on resource-oriented design. We would like to have communication collocated with code so we don't forget to update it, as it often happens. So the clear obvious for this is Open API, and we would like to enrich the resource representations to make the API more flexible. More about that in a bit. I've chosen only a few things to speak about from our core principles and best practices. This is not all of it. The response format, the resource-oriented design for us meant objects containing kind, metadata, and spec. So the kind helps in identifying the nature of the resource. Is it a secret, a project, or the deployment target? The metadata field contains all the non-functional information that helps identify and manage the resource. And the spec field contains the functional configuration or the desired state of the resource. This is where the actual content of the resource is defined. The rich resource representation for us started as objects instead of IDs, and this is what we have currently for created by, for example, instead of just providing the user ID, we will provide the object that qualifies the object type as user, and then we have the ID there as well. So this allows us to extend the API in the future with providing the backwards compatibility as well. Resources that are scoped to some parent resource, usually a project, usually also can be identified by name. That name might be used in multiple projects, and then nesting under project resource becomes necessary. So this ensures that resources, we prevent any ambiguity in cases where the same resource name might exist in more than one project. So also Semaphore's API supports some custom methods for performing actions that extend beyond basic CRUD operations. These methods allow the API to handle resource-specific operations like starting, stopping a workflow, for example, or any other needed actions. These actions don't follow the standardized resource object pattern, but contain only required information for that particular action. For these, we are using the resource path for identification, and we will try to provide actionable error messages if something fails. These actionable error messages we would like to have for everything, but let's say that we would like to especially have them for actions on the resources. I mentioned that co-located documentation is important for us, and the obvious choice was OpenAPI spec, as we want to heavily use it for documenting the API behavior. In the first efforts of specifying the API with OpenAPI specification, we stumbled into issues with mutually exclusive required parameters and decided that instead of trying to fit a square peg into a round hole, as they say, the goal is to change the API so it can be gracefully described by the spec and also rendered with commonly used tools. And that's why we are also excited about OpenAPI 4.0 talk that we've seen. I'll try to just be very brief here for the project structure. We have internal clients there. These are the gRPC clients that make the internal service calls between different components of the system. Each client typically implements mapping from request, so from the specification into internal API requests, and also the other way around. Responses are formatted from internal API into the specified API. Yeah, so into the specified API response format. In the project, you also see handlers. They are each one file per endpoint, so they are separate and easier to reason about. Each handler defines OpenAPI operation, and that allows for standardized data validation and validation errors. They each also define authorization permissions that are required for the operation. Also, they restrict or modify the behavior based on feature flags, and sometimes prefetch or combine data that is needed to perform the internal API requests. Hopefully, I've at least tingled your interest and you would like to see more and give some feedback or contribute in some way. We would be really happy if you did do that, and there are many ways to make the API better. And if you are interested, you can head over to this URL. We will provide it in the description or somewhere, and we'll be very happy to hear from you. Maybe we can go into the actual GitHub, and maybe I can give you a brief introduction. Let me see. Okay. So you would head over to Semaphore repository, and in the public API v2, we have a Elixir project. For those familiar with Elixir, they will know where to find the code in the lib, and then in the public API we have the main project. Here we define the routes that we have in the API. That's pretty self-explanatory, and yeah, except the trick is that we are not using Phoenix. So for the Open API specification to work properly, you also need to define the operations here in the API spec file. As you can see here, we have another thing is handlers. So let's see an example of one handler. Let's go to projects and maybe create. So the project always the handler always plugs this plug for casting and validating the request. This takes the request from HTTP into an object that you defined in the specification. We usually have audit logging there plugged as well, so we log the operations that are happening. We have the authorization plug that I mentioned and the permissions needed for it. If you go deeper, you can see the list of these possible permissions that we have documented internally, but we will share with you if you are willing to contribute what and how to handle those. And in the end, we have metrics and the actual plug that's the handler of this request. So we try to provide this, maybe not the best example, but we try to provide some documentation here as well. There are schemas which we can go and look later on. And basically the create handler is pretty simple. We just take the parameters that were cast by the Open API plug and forward it to the internal client, which then, let's see, the internal client. We have an internal client first. Let's maybe see here. This is the main module of the internal client. It defines all the operations that are there. And then this is, we are delegating the form request and process response. Those are the main ones to separate modules to keep this one clean and small. And let's see what project hub client request formatter holds. So we said create project. So we are forming a request for creating. We are using internal API, and let's see, project. We are basically building the internal API request here. And yeah, that's about it. All you need to know to get started contributing. We will also have some discussions open here on the repo, and we probably will have some RFCs opened for the public API as well. So see you in the pull requests and discussions on the Semaphore IO Semaphore repo. Bye.